My name is Billy Rennekamp. I'm going to be talking today about the Cosmos SDK, a module called Ethermint, which is an EVM module, and Peggy, which is a trustless implementation of a peg between probabilistic chains like Ethereum and Cosmos SDK chains. A little background about myself. I'm from Louisville, Kentucky, the home of bourbon, racehorses, and bluegrass music. I'm a developer relations engineer with Tendermint. I joined building the Looney wallet, which is a front end. I built the NFT module. I help with Ethermint, and new vertical is burner chains that I'm going to be talking about in a minute. Previously, I've worked with a group of friends with a studio doing dev and design. I've launched Clover's Network last summer, and I've also worked with Gnosis, Aragon, and Artblocks, and I'm an avid hackathoner, so look out for me this weekend. Quickly, I'm going to go over the evolution of blockchain development to sort of see what got us here. If anybody had the displeasure of trying to do something different around 2012 or so, you knew that the only real option out there was just to fork the Bitcoin codebase. All you could really do is kind of tweak the parameters, change a couple things, very, very small. You couldn't really make an application that was very different from Bitcoin itself. This did birth the first great wave of shitcoins that we all have come to love. But of course, later on, we had Ethereum, which birthed this brilliant virtual machine that you could not have to worry about building a blockchain yourself, but actually just deploy a dApp to it. This way, you could focus on app development instead of trying to secure a blockchain. This birthed the second great wave of shitcoins because it was so easy to deploy your own. But actually, it's been a Cambrian explosion of different protocols, products, ideas, devices, and it's been a real sort of hotbed for these ideas to be compounded. The problem is that with so many people in the same kitchen, sometimes they can't agree on what they want to do together. Sometimes the features don't match exactly. There's all sorts of growing pains that have taken place across Ethereum. You can think of Bitcoin as being something like a calculator, application-specific blockchain that does one thing very well, and that's all it does. With that in mind, Ethereum is kind of like a compatible time-sharing system. So back in ye olden days, you would only have one computer in a university, and you'd have to kind of get in line to have your turn running applications on it. You were a bunch of people all sharing the same virtual machine or the same actual machine. And Ethereum is a little bit like that today, which is why we have sometimes long waits for getting a transaction through, because we're all literally standing in line trying to run processes on the same machine. Another way to think about Ethereum is a bit like a local area network. So inside of this secured enclave, we have the ability to communicate with each other with a lot of really amazing trust assumptions. You can do these sort of money as Legos, compounding interest, building block stuff, which we all have come to love. But you are very much restricted to that local area network. And there's a concept that I'd like to get across today, which is the Internet of blockchains. Because Ethereum has its own feature set and its own sort of ability to do things it does, it is also restricted in those things, where there's another idea that maybe application-specific blockchains, similar to Bitcoin being a calculator, could exist but not be siphoned off. In that scenario, you would have an Internet of blockchains where you could route traffic similar to the real Internet. Following the TCP/IP protocol, you could use something called IBC to route traffic between blockchains, and each one could kind of do things very specific. Because at the end of the day, the Internet is not a single computer. It's a bunch of different computers doing different things at different times with different features, different security assumptions, different purposes, all connected through a protocol that they all agreed to use called TCP/IP. The Internet's also not a single stack. Every single one is different for its own reason, doing its different things, has different reasons to exist in different ways. So why should the Interchain be a single chain with one single homogeneous set of features? To enable this sort of vision of application-specific blockchains, people at Tendermint, we've been trying to put out the tools that are necessary to kind of build an ecosystem of trustless application-specific blockchains. The glue behind all of those is something called IBC, but in order to sort of speed the process up, we wanted to put other tools out there. One of them is the Cosmos SDK. This is a bit like Ruby on Rails for blockchains. So while the internet consists of a lot of applications and a lot of frameworks, one of the popular ones being Ruby on Rails, it's by no means the only one. We hope that it can be a great choice, especially if it has features that are needed for whatever network it's being built, whatever application is being built. But by no means is it the only one. One of the features of the Cosmos SDK is Tendermint. Tendermint is actually a product outside of the SDK as well. It's been integrated to the SDK so that you don't need to really think about it. But it's essentially an extension of years of research on Byzantine fault tolerance. It's been extended with the idea of blockchain networks in mind so that much larger validator sets could be used than traditional PBFT implementations. It also allows for interesting configurations with vertical scaling. So instead of trying to figure out a bunch of bells and whistles to shove a lot more people onto the same blockchain, why not just have a bunch of different blockchains for each application and connect them? Or if you have one application and you run into limits, duplicate it the same way you would with traditional web development. Have multiple stacks that communicate between each other, each one having its own sort of ability to have throughput. One of the nice things about Tendermint is that it has instant confirmation, so you never have to do this weird UX dance of saying, thank you for your transaction, please wait, 10 to 15 confirmations. I'm sorry, there was a chain reorg, we have an uncle now, I don't know what's happening, just give me a minute and I'll figure it out. With a confirmation, you know exactly that there's not going to be a chain reorganization. One of the other modules that comes out of the core SDK development kit is governance. So you have kind of voting out of the box. Three kind of things that can go through that are text updates, just sort of getting to agreement about some topic. You can put through parameter changes, which is essentially chain upgrades, live chain upgrades, also known as software upgrades. This uses liquid democracy for bonded stakeholders. So if you own tokens and you put them into a validator, you delegate them. You allow that validator to vote on your behalf unless you decide to vote differently. That's the beauty of liquid democracy. So I mentioned a couple times now, the thing that really brings all this together is IBC. This is the protocol that allows you to trustlessly send information between blockchains. And the way it works is you kind of take header information from each of those blockchains. You do a little handshake, sort of the same way TCP works. Hey, I want to talk to you. Hey, I acknowledge you want to talk to me. I heard that you wanted to talk to me. Hey, I heard you wanted to talk to me, that I wanted to talk to you. Now that we know each other exists and we've both established that we exist and we both have some record of our state, our headers, then we can start sending packets back and forth. Those packets come with evidence that proves they really came from where they came from so that they can be interpreted and used however those receiving ends decide to. Similar to TCP/IP, you can send packets to a computer that's not prepared to receive them or is ignoring 90% of them, and it's not going to break the system. It doesn't break TCP/IP. So you have two levels, this standard protocol of just sending serialized bytes, and then the application level where you actually receive them, decide to do something with them, interpret them, process them. This opens up this kind of configuration of a hub and spoke model. Here you can see the Cosmos Hub, which is a blockchain that is launched last year. It's meant to be basically the plumbing of this internet of blockchains. But like any robust system, it should never be a single point of failure. There's another hub being built out of China called the Iris Hub, and it can similarly function like this diagram. Because it makes a lot more sense to use hubs when routing these traffic instead of every single blockchain talking to every single blockchain at the same time. So what's really exciting about the SDK is that it becomes this sort of modular library system. So if you've ever used OpenZeppelin, you know that there's all these sort of well-tested libraries out there that you can just import and use. The SDK works like that. You have core modules that you see on the screen, but there's also modules being built in the ecosystem, a little bit like a Node package manager. One of them is Peggy. It's been built by Swish Labs, commissioned by the Interchain Foundation. And this is a module that you can import and enable inside of your app file. And it allows you to transfer messages between probabilistic chains like Ethereum and your Cosmos SDK app. With IBC, one of the requirements is that you have to have fast finality. So it doesn't have to be a Tendermint chain. It can be any sort of fast finality chain. Something like POA Network would be able to use it. Polkadot will be able to use it. ETH 2.0 will be able to use it. But ETH 1.0 cannot use it because it's probabilistic. You never know if there's going to be a longer chain, and it's going to disrupt this whole series of events. So what you do instead is you have a middleman, which is Peggy. Peggy has relayers that watch both sides of this chain, one on the Ethereum side and one on the SDK side. Whenever they see a packet coming from the Ethereum side, they wait some number of confirmations before they think it's okay, and then they manually transfer it over. Different Peggy implementations can have different security thresholds. So maybe there's a Peggy who has a 1 confirmation security threshold. A piece of Ether which has been transferred through that might have a lower value because the security guarantee is much lower, whereas a Peggy implementation that weights 100 blocks would have a much higher security guarantee and a much higher fidelity of value. Doesn't really matter exactly what your implementation is. The bottom line is that it lets you move things back and forth. You should know that the last week I have had many sleepless nights getting Peggy up and running because I wanted to use it for the ETHDenver Cosmos burner chain. This is a new vertical that I'm excited about. I mentioned at the beginning called burner chains, name taken obviously from the burner wallet, which was started here in Denver. And the idea is that it's a low security temporary blockchain used for events or just to demonstrate new capabilities. It has a life cycle built into it from the beginning. It's meant to come down. It can serve a purpose and then disappear just like a burner chain. So for this one, it uses Peggy, and it's connected to the XDAI network where the Buffer DAO process is running. So there's this game going on where people can learn these XP points. Every sponsor was given some number of XP. All of our XP are locked up on our burner chain. So if you go through our survey, you are given some XP on this burner chain, and then you can move it back to XDAI via our Peggy implementation. But that's not all. On this side chain, there's actually a game running. It's a scavenger hunt game and a riddle game. There's different questions that you would query the blockchain for that lead you to find different answers. If you find them, you submit them with a commit reveal scheme, and you get rewarded with more XP or with a new token called Brain Token. You can transfer these back to XDAI, and you can use them to redeem the NFT badges, which are also part of this Buffer DAO game. If you're interested in that, you should take a look at tutorials.cosmos.network/ETHDenver. Another module we're really excited about is Ethermint. It's been shepherded by ChainSafe and going to be in use, we're really excited about, by Aragon, coming up on the Aragon chain. Ethermint is an EVM module for the SDK. So say you have built this massive product on Ethereum, but you're running into scaling issues, you're running into sovereignty issues, and you want to redeploy your own independent chain, but you don't want to spend hundreds of thousands of dollars rebuilding all of your utility inside of Golang, which is what Cosmos SDK uses. You can sort of jumpstart that process of moving into a sovereign chain by using an EVM module. You can deploy your blockchain, have the EVM, and then redeploy all your contracts there. It works the exact same as the normal EVM module. It has all the same RPC ports. You can talk to it with Metamask. It's a seamless experience. It's just a different network. And you also benefit from all the things that come with the SDK. You can still have governance, still use the staking, IBC, all of these features of the SDK part of it, while having basically a sub-blockchain running through the EVM. I mentioned that this is a great sort of stepping stone for projects like Aragon to quickly move their entire stack over to an independent blockchain. But there's also really interesting things that become possible when you have an interaction between like a super blockchain and a sub blockchain inside of it. You can do things like hooks, so you don't do cron jobs and subscription projects that you aren't able to do in Ethereum. There's two hooks, the begin blocker and end blocker inside the SDK. So this is a function that'll execute arbitrary code at the beginning of every block or at the end of every block. So if there was some subscriptions inside of a smart contract, it could go through and make sure that all of those subscriptions are paid out at the beginning of every block or at the end of every block. This is a design pattern that's driven me crazy many times while writing in Solidity. I'm very, very excited about. Also, if you had some sort of a protected EVM, you could have the governance module on the Cosmos SDK be used to arbitrate which contract code could actually be deployed to the EVM. So you would make a text proposal or a proposal of a parameter change with the actual bytecode, with a description of what it does and the code, so that all the people who are stakeholders in the system could evaluate it, make sure the code is sound, is valid, and then only after voting approval would that approval go and actually deploy that code to the EVM. Otherwise, maybe you don't want anybody to be able to deploy. It's all sorts of like features that you can use to upgrade and trick out basically what the EVM does that way. So the thing that's really exciting now is that the SDK is finally at a point of maturity where we get to sort of run back through the amazing Cambrian explosion of concepts which have come up over the last couple of years, especially in the ETH space, and start doing implementations of them in Golang. Not restricted by the crazy EVM restrictions that come when you all have a really aggressive, what is the word? Adversarial environment like the EVM, because the Ethereum network is such a large and shared system. The EVM is built sort of battle ready and expecting the worst possible behavior because anybody can deploy code to the entire network at all times. Whereas if you're able to just design an application from the ground up yourself, it can be doing exactly what you want it to do with all of the features of a mature programming language like Golang. So I'm really excited to see more of these modules built out. I mentioned the NFT module is also available. There's a repo called Cosmos/modules where you can look for some of these that are already there, and as a potential project for the hackathon, we would love to see anybody who wanted to try their hand building a custom module. A lot of tutorials at tutorials.cosmos.network saying how to do that. And we have $5,000 for hackathon projects. Quick ideas of things that I would love to see. Complete Peggy with NFT transfers. I mentioned that Peggy's doing token transfers right now. There's a half-done NFT transfer implementation that if you just pushed over the finish line, I think would be a great project. Connecting Peggy to Ethermint. So say you wanted to do arbitrary messages between two EVM chains. In order to put a destination and the call data, it's just different fields than token name and amount. So it's not such a big change from what's currently happening. Conversion between Ethermint ERC20s and Cosmos SDK coin type. So on the SDK, you have a data type called coin, which is essentially a ERC20. And inside of the EVM, you've got contracts where you can deploy an ERC20. But say you want somebody inside of your Ethermint implementation to be able to transfer their ERC20s into like the wider Cosmos ecosystem through IBC. You would need to have some programmatic exchange between that EVM module and the coin module. So we'd be able to say, here's like a designated burn address. Whenever somebody sends it to that burn address, it'll mint a coin inside of this other module inside the stack. That coin becomes a full-fledged member of the SDK sort of programming environment, but it could also go back. So that's something that I would love to see, and I think actually that ChainSafe is working on it because Aragon will be using something similar. Front-end interface for the Peggy burner chain. So if you go back to those instructions that I mentioned, it'll tell you how to access it and how to query it, how to submit answers, but all of that is done through the command line. If you're interested in building an interface for that project, I think that would be also a really good one. And a high scores REST endpoint. So high scores are essentially just token balances. And currently, it's a little tedious to try to get all of the token balances of every user on a Cosmos chain. All of the pieces are there. They're just not built into a REST endpoint. So modifying the REST client to query all addresses and then getting them by balance, maybe with pagination by clipping it at numbers at a time or even sorting it. Those would be all really, really cool projects that I would love to see. Also to mention, upcoming is Game of Zones. Last year, we ran an adversarial testnet called Game of Chains. My brain is melting right now. It's an adversarial testnet. So before we launched, we wanted to make sure that nothing terrible would happen. So we decided to pay people to make something terrible happen before the network went live. We're essentially doing something similar now with IBC. IBC is spec complete, and the implementation is almost finished. Once it's done, we'll begin Game of Zones. You'll be able to spin up your own chain and start talking to other chains. If you can do anything nefarious in that system, if you uncover bugs, if you can attack somebody, any of that kind of activity is rewardable up to 100,000 atoms. You can learn more at cosmos.network/GOZ. And last but not least, we are always hiring. Take a look at our site, Cosmos Network, learn more about us, see what is going to be the Internet of Blockchains. Do I have any questions? I did that good. I just filled you all's head with knowledge to the point. Yes? Any plans for a public chain? So Cosmos is a public chain, the Cosmos Hub, excuse me. These are all other public chains. Some of them are just concepts, some of them are actual chains. There are, I think, $5 billion worth of assets currently secured by SDK chains right now. Although without IBC, none of them are talking to each other. So this is the last kind of final hurdle to connect this concept of the Internet of Blockchains. But most of them to this point are public. The beauty of this is that you actually could have private networks communicating with public networks in a trustless way. Anybody else? My name is Billy Rennekamp. Let me get that back up. If you'd like to follow me, I'm on Twitter with the same name, GitHub at OK with me. You can check that out in tutorials. Thanks for coming.